God kväll. Jag heter JB eller Joe Rainsberger och jag talar lite svenska. But I'm going to switch to English because that'll be much better for everyone. But I wanted to make sure to, at least now I can say I spoke Swedish in front of a Swedish audience. Next year you can expect better. We'll see how it goes. So apparently I chose the wrong title for this talk. If I had called it Surviving Your Inevitable Lean Transition, apparently there would be 10 times the size of the audience. I guess Agile's not cool anymore. Which is actually part of the reason why I wanted to talk about this stuff, because I think part of the reason Agile isn't cool anymore is not that Agile isn't cool anymore, it's that I think we have a lot of wrong ideas about what Agile was supposed to be. And that affects how jobs go, especially in bigger organizations around the world, and I imagine there's going to be some of that here. So now that big companies have heard about the term Agile and have decided that, ooh, that's good and let's do that, there's a whole bunch of chaos, and I think a whole bunch of misunderstandings and a whole bunch of bad feelings and terrible consequences for us as people stuck in those situations or not stuck in those situations. I especially feel bad for anyone who is looking for work and can only find opportunities at companies that are going through these Agile transitions. And so I wanted to talk about two kinds of things. One is really what was Agile supposed to have been about, and the slightly more cynical view of, if you're living through an Agile transition, how do you get through it without wanting to kill yourself or others? Which is a non-trivial risk. So that's kind of what I wanted to talk about. Before I move on, I don't want this to be me telling the whole world that they did it all wrong. There are enough people who do that, and I'm not here to do that, but here to try to reinvigorate some of the ideas that made Agile, and especially, I think, extreme programming very promising when they were first repopularized in the late 1990s and early 2000s. You might not know, it's actually an accident of history. The reason that we're using the word Agile is because people at the Snowbird meeting, when they came up with the Agile Manifesto, didn't want people calling them lightweights, which is why they didn't choose the term lightweight, which is really what they wanted. And it's really ironic to me that one of the big things that has happened in the last 15 years is that somehow the lightweight notion of, yeah, you're laughing already. So the lightweight notion of Agile has completely disappeared, and Agile has become the new enterprise software development lifecycle. I don't know how that happened. It certainly wasn't what any of us intended. As speaking as someone who was sort of in the second wave of Agilists, I got to learn directly from a lot of the pioneers. Names that actually by now are kind of meaningless. I mean, some people know who Kent Beck is, and some people know who Ward Cunningham is, and some people even know who Ron Jeffries is, but there's a whole bunch of people that I learned from who no longer have recognition within the Agile community that they helped create, which I find kind of curious. So I want to start by talking a little bit about so I've got just 6 random topics, and we're going to see what happens. So if you're expecting structure to this, I apologize. If you're expecting the topics to flow one to the other, I apologize. There's probably going to be a few abrupt stops and change of topic. That's just the way things are. There's a few things I want to kind of get off my chest. And the first one has to do with, there's still this weird feeling that Agile is meant to be a replacement for waterfall. And I want to get that one out of the way. I think one of the there's a lot of misconceptions even just about what waterfall is. So I'm going to draw one of these diagrams that you've seen a million times before, so I apologize for making this the 1,000,001th time that you see it. So here's our good friend analysis, and then after that is design, and after that is coding, and after that is testing, and then after that is maintenance. But we really don't call it maintenance anymore, we call it operations, because that's more interesting. And I think when you say waterfall, most people think about this diagram. This is not the waterfall. This, at best, is the single pass waterfall. If you read Winston Royce's 1970 paper, where he introduces this diagram, he says very clearly two very important things. The first one is, this is risky and invites failure. He says that right underneath the diagram. I think it's like 2 or 3 sentences later. He also says that this works only for the most straightforward projects. In other words, if we already know the technology, and we already know the domain, and we already know each other, this could be an efficient way to deliver software. I don't know about you, but I can't remember the last time I was on a project where I knew the technology well, and I knew the domain well, and I knew my coworkers well. I mean, that just doesn't happen anymore. If you know the coworkers well, then the domain is changing. If you know the domain well, then the technology is changing. If you know the technology well, then the people are changing. So this could work in a narrow set of, and not actually a student says, this could work better, more efficiently, in a fairly narrow set of circumstances that none of us seems to live in anymore. And I wonder whether any of us lived in it at all since 1970. Maybe not very many. Now, the other thing to keep in mind is that this diagram was, as I said, this is diagram on page 2. And one of the first things he does, and I'm not sure I'm going to draw this correctly, but one of the first thing he does is he draws this. He says, you know what? What really tends to happen more realistically is that there is a loop from testing back to coding and from coding back to design. That this is natural, that we can't write code without finding holes in our idea about the design. And we certainly can't test our code without finding out that it doesn't quite work. And then if you flip over a few more pages, you actually see this horrific diagram where he effectively shows arrows from every phase to every other phase in both directions, which means they're not phases at all. It would be equally effective to draw a diagram that looks like this. That is just a big circle, and we do all the activities all the time. Now, the big difference between, and this is closer to waterfall. The difference between waterfall and Agile really is simply the length of the iterations. Let me say that one again. The difference between waterfall and Agile is really the length of the iterations. Waterfall-ish stuff tends to be longer iterations, and Agile-ish stuff tends to be shorter iterations, and that's really the only difference. Maybe in waterfall we expect these activities to happen in a certain sequence, whereas in Agile it's maybe a little more like this. It just sort of all happens. The funny thing is that as the cycles get shorter and shorter, I can't tell the difference between those two things. I can't tell the difference between doing all 5 activities in a few minutes and jumping around from one to the other seemingly at random. So that's really, when people talk about the difference between waterfall and Agile, there really isn't much of one. Waterfall is Agile done really slowly, and Agile is waterfall done really quickly. And that's it. The common enemy to waterfall and Agile is chaos. That's really what we're both trying to get rid of. The only difference between the waterfall approach and the Agile approach, in my opinion, is actually similar to the way people think about design. The way they think about design before they write code. So let me draw here's a little spectrum. And this spectrum is the amount of design the number of design decisions I make before I write the first line of code. Okay, so if for the programmers in the room, if I describe a programming task to you, a problem, you immediately start designing the solution in your head. You're a programmer, you can't help it. As soon as you start doing this, you start making some design decisions in your head. Now the question is, how many design decisions do you stick with? before you write the first line of code. And at this end, we have none, and at this end, we have all of them. This is what a lot of people refer to as big design up front. And so where does test-driven development fit in here? Well, the first thing I want to point out is that nobody lives at either end. Nobody, when I say, hey, I want you to do this thing, you immediately start making some design decisions. So you certainly don't live here. You make a few decisions in your head that make sense to you at the time, and they're going to guide your choices the rest of the way as you're actually building something. At the same time, nobody lives over here either. Nobody sits down and draws the perfect design diagram to the perfect level of detail before they write the first line of code. They're crazy if they try. They know it doesn't work, even if the process tells them they're supposed to do it. So now we're to question of negotiating where on this spectrum do you work. Human nature encourages us to move to the right whenever we encounter a problem, a mistake, some doubt. Human nature encourages us to fix the problem by thinking harder about it next time. If I had just thought harder about it for 15 more minutes, I wouldn't have made that mistake. Test-driven development encourages us to go back in the other direction. It says, look, there's a limit as to how hard you can think for how long before the value is no longer. There's a limit to how much and how hard and how detailed and how focused you can think about something before you start to do it. TDD says, look, we allow for the possibility that there are some things you will not discover until you write code. And in fact, until you write tests. There's some stuff you simply cannot foresee until you try to do it. So test-driven development is a discipline for encouraging us to move in the direction of fewer design decisions up front. And human nature does its best to encourage us to just think harder about it before we do it. And these two, I wouldn't be in diagram if I didn't have opposing forces, right? So these forces oppose each other, and that's why we do test-driven development. We do test-driven development to counteract the human nature that pushes us in the direction of never actually writing code. Software would be so much easier if we could simply write code on Turing machines in our heads and there were no customers to bother us. But it's not terribly lucrative. You can do it, but you can't make a living at it. Well, maybe 2 people in the world can make a living at it. I'm not one of them. So at some point, we do need to write code. And so TDD says, look, we make mistakes. Let's figure the mistakes out as quickly as possible, drive the cost of those mistakes down, and everything will be fine. So these two forces are pulling at each other. Well, I think exactly the same thing is true here. The waterfall mentality says when we do something wrong or aren't sure what to do, we err on the side of thinking about it harder or longer, writing more documents, arguing about it. Agile says, no, if we are making mistakes, we're not getting feedback quickly enough, let's get it more often. If we're not sure what to do, let's get feedback more often. Let's go try to run an experiment. Let's try to figure it out that way. Let's admit that no more thinking is going to help us. Now, it's worth pointing out that, again, nobody can live over here. Nobody is suggesting, now that's a stupid way to say it. I'm not suggesting that we should not think about stuff before we do it. Just like step 1 of test-driven development says, think about what you're trying to build and then think about what API would be a good way to package it. Agile doesn't mean that we start on day 0 at 9:01 a.m. on the keyboard. We still do think up front about what we do, but we don't try to figure out all the details up front, nor when things go wrong, do we pretend that just a little bit more thinking would have avoided the mistake. Instead, we say, look, we think about stuff, we make a good guess about where to start, we try to get comfortable starting to actually do the work early instead of late. And then we do all these things almost exactly in the opposite order. We gather feedback, and then we use that to decide what to do next. So in that sense, waterfall and agile are really just opposite sides of the same coin. It's just that the waterfall mentality tends more towards solving problems by thinking harder, and the agile mentality leans more towards solving problems by gathering more feedback. I think they help each other. Lean startup is way over here. There are some startups that really could have avoided a lot of mess, just thought for 15 more minutes about whether their idea was a good idea at all. Yeah, it's good to get out of the building, but it's also good to realize if I can't name 5 friends who would buy what I'm trying to sell, maybe nobody else will buy it either. That might be just enough thinking to get started. Okay, so I hope at a minimum that I've helped establish that waterfall and agile are really not that much different from each other, that it's a question of scale and it's a question of mentality, that they in fact do help each other. And so if we're having trouble shipping software and we think we're waterfallish and we think that switching to agile is going to help us, the odds are very good that we're setting ourselves up for a situation where we just use agile words for the old waterfall ways of doing things and nothing actually changes. And especially if we try to, if at least embrace the idea that agile encourages us to solve problems by gathering more feedback instead of by thinking harder, because human nature encourages us already to think way too hard, then we've missed most of the point. So in the cynical sense of agile transition, if you're in an agile transition and it looks like it's just, let's just take the waterfall and replace, we'll replace this with user stories, and we'll replace testing with stabilization sprint. We'll replace this with DevOps. And design and coding are just one thing now. This is no more agile than what you had before. This is just waterfall with different words. It's exactly the same as it was before. In fact, what's probably true is that it's chaos with different words. So at least encourage people who, if there are people around you who are making a show of an agile transition, who don't seem to really understand any of the, like they can say all this, but it doesn't seem that it's really any different from what we did before. At a minimum, encourage them to think about this one simple idea. That look, waterfall simply means when in doubt, think harder, and agile simply means when in doubt, gather feedback. That little shift can make a big difference. So when we talk about agile as a mindset and agile as a way of thinking, and you can't do agile, you have to be agile. The being agile part simply means that under stress we gather more feedback instead of think harder. I mean, if thinking harder were all it took to solve these problems, we'd have solved them by now. Because we just by nature try to think harder when things go wrong. What should I have done? What should I have done? So, to me, if nothing else, agile is really about when in doubt, gather feedback. Run an experiment. I'll come back to that a little bit later. Now, there isn't just the mindset idea of agile that is different from business as usual. There's also the financial economic aspect of agile that makes it fundamentally different from the waterfall mindset. And I'm not here really to compare stuff to waterfall anymore, but again, what is the essence? So if an agile transition mostly just consists of using agile words to describe what we're already doing in an effort to make it look like we're doing something, what could we be doing instead that would actually deliver value? And that word value is an important one. So there's one fundamental economic or financial aspect or goal of Agile. And it has to do with something that the business world likes to call early earned value. Sometimes they call it realizing value, in the sense of making real. Because there's potential value, and then there's real value. So potential value is things like, goodwill, standing in the community, market share, mind share, all that kind of stuff that doesn't actually translate to anything real. And then there's real value, which I like to call cash in my pocket. This is real value. Early earned value is essentially cash in my pocket. Or if you want a better term that's less silly, then how about simple cash flow or cash on cash return? I invested this much cash. In 6 months, I got that much cash back. Divide this by that, I get a percentage. That's my cash on cash return. 137% in 6 months. One of the things that makes Agile software development different, or I should say should make Agile software development different, is the basic assumption that the overall goal of the business is to improve early earned value. Now, you look at that and you think, well, what the hell else could they possibly care about? And let's not even go into the cynical explanations of empire building and political maneuvering and all that kind of stuff. Like, what other financial motivation could there possibly be? Well, cash on cash return there's also the generalized idea of return on investment. And return on investment isn't always about cash coming in. Return on investment could be about the value, appreciating the value of assets. Right? If you buy a house and the house appreciates in value by 10%, that's not extra cash in your pocket. The theory is that when you try to sell the house, you have pretty good odds of being able to sell it for 10% more than you paid for it. But that's not cash in your pocket right now. Cash on cash return is not the same as return on investment. Return on investment is what would the total cash be back, what would the total cash returned be when I sold off the asset? So ROI has cash on cash return plus appreciation. And you can have really high ROI and run out of money. The simplest way to do that is to extend everyone credit. And then you have lots and lots of receivables on the books, but nobody's actually paying you. So you have lots and lots of money, no cash. That's a terrible place to be, lots and lots of money and no cash. I've had that experience as a consultant, and let me tell you, it is not fun. So when we focus just on ROI, we might be willing to invest an awful lot of cash and actually go into cash debt with the bet that there's going to be a big payoff at the end. And we might do this because we can survive this period where a lot more cash is going out than coming in. We might have cash reserves hanging around. We might have a friend at the bank who gives us more than enough credit, and we think we're going to survive it. And so I'm not going to say the waterfall mentality encourages this, but there are some people who, in many situations, this is all they care about. If I have lots and lots and lots of cash reserves, then I'm happy to survive a period where I've laid out a lot of cash and not much is coming back, right? Maybe this is actually the first point where we're now cash flow neutral. And after that, we have positive cash on cash return. Here's my question. How long does that take? 6 months, a year, 2 years, 5 years, 10 years? Who knows? So ROI and cash on cash return are not the same thing. And sometimes people say this when they really want that. See, cash on cash return is important when cash is the bottleneck. When you can't afford to shell out hundreds of thousands of dollars over the next 6 months on the bet that you're going to make the big $1.7 million sale. Agile, generally speaking, takes the assumption that we actually care more about early earned value than we care about long-term return on investment. That in fact it's more important for us to have more cash sooner than it is to maximize our total investment over a longer period of time. And so it's possible that early earned value will go up and total return on investment over a 5-year period will actually be lower. But if we're bootstrapping the company, if it's your money, you might be concerned about seeing some cash earlier than 4 years from now when we're going to make that big $1.7 million sale. It's a lot easier to worry about this when it's someone else's money. When it's your money, this cash flow tends to be a lot more important. So one of the fundamental ideas in Agile software development that makes it work is that our goal is to get to the point where we are making cash flow sooner. I like to call it turning the tap on. I want to turn the tap on sooner. That doesn't mean figuring out how to build software the most efficiently possible so that at the end of a 5-year window we've maximized our sales ability. It's, look, even if it's going to make us go slower over the next 5 years, it's really important that we survive the first 6 months or the first year. So we need to figure out how to build an interim product that helps us get over the first 6 months, cash flow cash self-supporting. After which, now we can play the longer plays. If you don't have this discussion with the sponsors in your environment, which you might even be in a company where having this, there's no one who's willing to have this discussion with you because you are a lowly peon and they are a vice president. Or it could be that you're also an owner and you hadn't thought about this before. You don't have this discussion, then you have no way of knowing whether the people who want to do Agile really want to do Agile. Do they want to do Agile because they want to increase early earned value, or do they want to do Agile because they want to be seen doing Agile things? This is this notion I have that Agile has become more of a fashion accessory than it has been a process or a method or an approach. That it's more important to be seen doing Agile things than it is to actually derive the benefit. But from what I can tell, there's no Agile method that doesn't make the assumption. So let me say that in a less confusing way. Every Agile method makes the assumption that we care more about early earned value than we do about long-term return on investment. And so if they want this, and you're giving them Agile, you're making a mistake. You haven't established that the core idea behind Agile is actually the thing that they want. They might not even have thought about it. Right? We have this gap problem where the CEO says, yeah, that all sounds great, go Agile. But at the bottom, they don't know what the CEO's motivation is. The motivation could be purely political. It could be purely to position themselves as the next great consultant company, and Agile seems to be a hot topic now, so I'm going to jump on that train while I can. Or they might actually genuinely be trying to save the company by getting cash sooner. We've been doing this for a long time, and we now realize this was a terrible idea. Let's get cash flowing now. Let's go Agile so that we can get cash flow. But if you don't have that discussion with them, you're not going to know.
But let me ask.
Sure. Mm-hmm.
The bigger the company gets, the harder it is. You don't really have I don't have a discussion with my CEO at a huge company about.
Right, but at a huge company, you probably don't need to have the discussion with your CEO. So it's a good point. In a large company, you're not going to have this discussion with the CEO. But in a large company, you're not going to need to have the discussion with the CEO. It might be with somebody who reports 2 levels down from the CEO, who is the head of your business unit. And you have that discussion with them because they're going to have a budget and they're going to run their business unit like a little company.
Yeah, sure.
And so, say again?
It does add complexity.
Oh, absolutely adds complexity. There's no question. And I think that one of the biggest problems that we have with agile transitions in larger organizations is that they haven't thought about why they're doing it beyond the cynical reasons. And so we come in and we very earnestly and thoughtfully say, look, okay, you want to go agile? Cool, that means that you're focusing on cash flow and early earned value, and that's why we do user stories this way. That's why we plan every week. That's why we're doing test-driven development. All these things are in support of early earned value. And then the person who thinks they ordered 123 kilos of Agile starts saying, what? I don't care about any of this stuff. Well, if you don't care about any of this stuff, then why did you ask for Agile in the first place? Unfortunately, a lot of them don't know what they're asking for. They just know that Agile is fashionable, that it's the Dilbert joke is that we're going to do this thing called Agile programming. And that's where, we're going to do everything the same way in half the time. And that's not uncommon. Yes, you know what? We can actually probably generate the same value with half the resources because we get to the point where we are in fact self-funding faster. So there's an aspect of that, the same stuff in half the time, that's actually quite true. Because if we can establish that we're self-funding sooner, then we can actually generate the same value with half the investment. But they hear, I'm going to do the same thing in half the time. And that's not really what we mean. We're going to do the same thing with half the money. But that's because we're going to focus on this. So one of the transformative books of my personal life is Rich Dad, Poor Dad by Robert Kiyosaki. I'm going to sound like a cultist for just a moment, okay? The big transformative idea in Rich Dad, Poor Dad is really understanding what the terms asset, liability, income, and expense mean. So I won't read the book to you, but here's the joke. When your banker tells you that your house is an asset, your banker doesn't tell you whose asset it is. It's not yours. It's theirs. A liability is anything you own that costs you money. And an asset is anything you own that makes you money, whether you do work or not. So your house is for sure a liability. And if you're not sure, try to stop paying your property taxes and see what happens. So the idea there is that we get rich by using our money to invest in income-generating assets. And then that compounds over time. What that means is that we don't invest to maximize long-term return on investment. We invest to increase cash-on-cash return because that cash is now liquid. We can use that to buy more assets that generate more cash and buy more assets that generate more cash and buy more assets that generate more cash, as opposed to, say, the Warren Buffett approach. Put all your eggs in one basket and watch that basket really closely. That's maximizing long-term ROI. That's focusing on unrealized appreciation over time as the primary way of building wealth, which is great if at some point you sell. But in the meantime, you're eating cat food because you don't have any cash. It's all tied up in this investment. That's why we bought rental properties instead. And we get cash in our hot little hands every month, and we use that to buy more properties and more properties and more properties. That's the fundamental difference. So for me, Agile is at its core also about early earned value or cash in my pocket. And that if we don't include that in our discussions about changing how we build software, we're going to miss most of the benefit. Okay. Let's see where we are on the list and how we're doing. I'm going to do that part, but I'm going to do it real fast. All right. There was a slide from one of Martin Fowler's talks that went around Twitter about a month or two ago that I absolutely adored. And he talked about justifications for refactoring. So just to back up for a second, when I say refactoring, I mean it in its clinical sense. Changing the design of a system without changing behavior that we care about. So it behaves the same way as far as we can tell. And the purpose of refactoring is to make it easier to add a new feature or fix a problem. That's it. That's all refactoring is. I've met managers who thought that refactoring meant add new features. That's why I bring this up. I want to make clear about how I'm using the term. And he had a slide that said, justifications for refactoring, because apparently we have to justify this to our overseers, which is funny, because when a manager asks me, why are you refactoring, I say, oh, I didn't realize you were writing code with us today. If you're writing code with us today, then let's please talk about refactoring. And if not, will you please go away and let the professionals write code? I used to think this was a good way to handle the situation. I have since learned that this is, while it is true, it misses something important. And that is related to this early earned value issue. So the only proper justification for refactoring is money. All other reasons are nonsense. We don't care that the solution is more elegant. We don't care that the solution is cleaner. We don't care that it makes programmers feel happier. Well, we care a little bit because there's some indirect benefit there, but that's not really compelling to me. The only reason to refactor is to reduce volatility in the marginal cost of a feature. Cool, we all understood that. Great, let's move on. All right, I did that for fun. Refactoring is about reducing volatility in the marginal cost of a feature. So just some quick vocabulary, right? Marginal cost just means the cost of the next one. So the marginal cost of a feature is simply the cost of the next feature. Volatility, I think we all understand. You have, if you're a programmer or have been at any point in the past, you've been in a status meeting where you discussed a feature and you said, great, that'll take 3 days. And then you go on Monday and you try to start building it and you look at the design and you go, nope, 3 weeks. Because you've hit part of the code base that's in trouble. The design it seems as though it actively prevents you from making changes. I saw a great tweet this past week from, I think, Lean Agile Scotland. They said that legacy code means that the system is making more design decisions for you than you are. Right? So, again, the purpose of refactoring is to reduce volatility in the cost of the marginal cost of features. How does that work? Well, essentially, if this is adding features over time, that should be kronor. If this is adding features over time, the cost of adding features over time, if we don't pay attention to the design, tends to look like this. Yes, I do genuinely believe it's exponential. You've experienced this if you've ever gone through a project that lasted for long enough that at some point they fired the CTO. This is the moment known as project heat death. Project heat death is when the cost of continuing is higher than the cost of starting again. So they fire the CTO, the new CTO comes in and says, I'm glad to be here. I can't wait to meet each and every one of you. We're going to throw it all away, start again, and do it in Python and get it right this time. So if we don't pay attention to the design, and we just keep piling stuff on top of stuff on top of stuff, without really trying to make things better as we go, this is what happens. Eventually, the cost of starting over is lower than the cost of continuing on. In big enterprises, the saying is, we can never afford to do it better, but we can always afford to do it again. And it's sad. We've seen it happen. Now, refactoring is about trying to bring this under control. So now imagine that we cleaned the kitchen as we went. So I use the notion of cleaning the kitchen for the refactoring that you do as you write code. Not the refactoring tasks that you schedule for the weekend when nobody's looking. That's cleaning the garage. That's a different issue. But we know if you've cooked, and I've been cooking now for 25 years, if you don't clean the kitchen as you go, then eventually there's nothing left to cook with or there's nothing left to cook on. And it takes hours. Think about how much harder it is to clean stuff when it's been sitting there for 4 hours compared to when the pan is still warm. That's a really simple way of thinking about it. So cleaning the kitchen refactoring is the refactoring that you naturally do as part of designing things, where the idea in your head about how you would design it turns out not to work quite right, so you make some changes and you clean things up as you go. Or, I'm not quite sure how to do this, so I'm just going to type like this until it works, and then I'm going to fix the design. I see some duplication, I'm going to remove that. This name is kind of weird, now I have a better idea what's going on here. That's the clean the kitchen kind of refactoring. Clean the garage is when you have lots of problems and you don't actually fix anything until there's no longer room for the car in the garage. And that's when you say, fine, I know you've been bugging me for 4 months. I'm finally going to clean the garage this weekend. And you clean it just enough to make sure the car fits. And then you have to do it again 4 months later. This is one advantage to not driving. I don't have this problem. When you clean the kitchen as you go, the cost of features over time looks a little bit more like this green line. Now there's a couple of things I want to point out about this green line. The first thing is this green line is not flat. I make no claim whatsoever that we can keep the cost of adding new features flat. Nobody can do that. Anyone who claims they can do that is full of shit, and you should tell them to leave. It is slightly curved, and it is rising slightly. Slightly. It's probably exponential, but the exponent is so low that it's not going to hurt you. You know, it might be e to the 1.000002. Probably you can survive that. For your purpose, that's linear. I'm not going to get into Chebyshev approximations. I don't know if I remember how to do that. You can pretend it's a straight line. It's a straight line that is sloped slightly upward, so the cost of adding features does increase over time. I have noticed that the cost of adding features to for a team that designs well and refactors and cleans the kitchen as they go, the cost of adding new features tends to rise depending on how long the team has stuck around together. But occasionally you have to inject new blood to get that lowered a little bit. You'll also notice that the green line starts higher than the black line, which means that the cost of the first n features, 10, 15, 20, doing it the careful way, is actually higher than doing it the not so careful way. And that's actually that's the scam. The scam is that not paying attention to the design actually means that we can get out of the blocks quicker. Now, acceleration and getting out of the blocks is the most important thing in the 100 meters. In the 400 meters, you finish last. You need to be able to do more than just get out of the blocks quickly. Now, there's a couple things that happen here. First, again, you'll notice that the cost of the first few features is actually quite a bit higher than it is doing it the not so careful way. But eventually, you reach the point, and I know I haven't drawn this to scale. Let me draw it a little bit closer to scale. It'll make the point I'm trying to make a little bit less silly looking. So let's say we're more like here. So I won't make you do the calculus, but trust me. There's a point at which the area under the two curves is the same. Eventually you reach the point where the cost of getting out of the blocks quickly and not worrying about the design is about the same as the cost of being careful from the beginning. This is the crossover point. This is the break-even point. Right? And after this, being careful is nothing but profit. And in fact, it becomes more profitable over time. Object Mentor, the American company that has provided both object-oriented design mentoring capabilities as well as being in the extreme programming and Agile space for a long time, likes to say the only way to go fast is to go well. This is what they mean. To go fast over time requires going well. Or maybe said differently, if you go well for long enough, you'll beat going fast every time. You'll be faster than so-called fast. Now, when somebody tells you not to refactor, don't waste all that friggin' time refactoring. What they're doing is they are betting that they get to leave the project before the crossover point. That's literally what's happening. They might not be doing that consciously or intentionally, but that's literally what they're doing. They are betting that they're going to leave the project here, and you're still going to be on the project here. So that when you guys are saying things like, it's taking 4 days to do 15 minutes worth of work, real numbers, by the way, because of all the crap around you, that's someone else's problem. When it happens here, it's my problem. When it happens here, it's someone else's problem. So that's one of the reasons that I kind of justify that reaction to the manager and say, are you writing code with us today? To get them to understand that what they're telling us is, so when you tell me not to refactor, what you're telling me is I should get off the project before the cost of before this crossover point. And since I don't know where this crossover point is, what you're really telling me is I should get off this project as soon as possible. Because the problem is we don't know where this point is. We know the shapes of the curves, but we don't know the constants, so we can't calculate T0. It'd be great if we could. I'd have a Nobel Prize if we could. I'm sure as hell not going to stick around to find out when. So, this is why we do evolutionary design. We don't do evolutionary design because it's better. We don't do it because it's the programming equivalent of eating your vegetables. We don't do it because it's fun. We don't do it for any of those reasons other than reducing the volatility and the marginal cost of features. And anyone who tells you that they have another motivation for refactoring has missed the point. I'm not giving those people my money. Now, the funny thing is that I spent a lot of years refactoring before I understood that refactoring has as the goal the reducing the volatility and the cost, the marginal cost of a feature. So it's kind of a good idea to find that out as soon as you can. But that to me seems to be related to this early earned value, right? Because why do we want to reduce the volatility in the marginal cost of a feature? It seems to me that if I have a difficult time computing or predicting or forecasting the cost of adding a feature, it's hard for me to plan. And if it's hard for me to plan, it's hard for me to know whether my investment is safe or not. And if I don't know whether my investment is safe or not, then there's a very good chance that I'm going to start doing some very odd things out of desperation. And I'd like to avoid that. Not only that, but when the marginal cost of a feature goes up, then it's harder to get early earned value, and I don't get cash in my pocket as quickly as I'd like. There's this weird thing that happens that when we reduce the volatility and the marginal cost of something, that eventually also the overall cost goes down. Yeah, so as you say, it's a hard sell because people are just absolutely seduced by the beginning part of that curve. And, you know, people are seduced by a lot of things that are very bad for them, and if the time it takes for them to find out the feedback that it's bad for them is too long, then they're not likely to avoid it, right? It's the same for a lot of people with eating sugar or drinking alcohol or smoking or any other kind of literally toxic behavior. I mean, alcohol is toxic. We drink it anyway because we get some value out of it that is just beyond the risk of the toxins. So changing that behavior is a hard sell too. So how do we do it? I hadn't intended to talk about this, but it does bring up questions about motivation and selling. And I don't want to go into the details here, but I will add just as a little extra bit. There's a wonderful book called The New Strategic Selling. That includes, this is a beautiful sales book for programmers. You wouldn't think such a thing would exist, and for sure they did not intend it to be this. The reason that I call this a sales book for programmers is that it includes in it a model for how to debug a failed sale. It's fantastic. And at the heart of the model is the notion of a personal win. So let me illustrate personal win for you. about 15 years ago, I was a programmer at IBM. I had about 2 years of experience. I was trapped in a loop where I would write a bunch of code. I would say, great, I'm done for the day. I would go home, and then I would come back the next day, and there would be a stack of bug reports waiting for me from the code that I had written the previous day and some earlier stuff. So then I would go shit, and then I would go try to convince the tester that they were in fact features, not bugs, and he would have none of it. And then I would sit down and I would fix the problems that I made. There would still be a little bit of time left in the day. I'd go back into a trance, write more code, go home feeling like I did something, come back the next day, more bug reports. And it got to the point where I started to feel tension in my chest because I felt like no matter how much I did, I never finished anything. Because when I thought I was done, I wasn't really done. There were bugs. This was causing a problem for me. Now, when I say I felt anxiety in my chest, I am not lying and I'm not exaggerating. I actually felt a little bit like pre-heart attack pains in my chest. And I knew I had to do something about it. And that's when I typed into a web search engine, which wasn't Google back then, how to test Java code. And that's how I got on finding out about test-driven development, about JUnit, about extreme programming, and all that stuff, and that's how I got here. Now, why did I do test-driven development? Not because it made my code better, not because it made my designs better, not even because I could reduce volatility and the marginal cost of features. I got it to make the pain in my chest go away. Somebody said, you know what, if you try this, I bet it's going to make the pain in your chest go away. And I said, nothing else I'm doing is working. I'm going to give it a shot. That personal win was I get to go home and feel good about what I did that day and put it out of my mind. And when I come back the next day, even if there's a bug waiting for me, it's not the end of the world. I can now see that I can approach the finish line. I'm no longer feeling like the finish line is moving away from me faster than I'm approaching it, which is where I was before. That was the personal win. That was what gave me the confidence to then say on my next project, when I reached that point where we were totally screwed and I couldn't patch the holes any faster than new holes were springing up, to say, look, let me go home. I'm going to build it again. I'm going to use this technique called test-first programming, which is what we called it back then. And it's the only chance I can think of that will allow us to finish on time. And if I don't finish on time and you have to fire me, I accept your decision. And I did. I went home and I did 3 months of work in 9 days, 9 14-hour days. Towards the end, I was making 4 changes an hour because it took me 12 minutes to run all my tests because I didn't know how to write good tests and I was using a Pentium 90. Some of you don't even know what Pentium 90 means. That's how old that was. That was the personal win that helped me be willing to try it in a more serious way. That was the key thing. No rational argument, no financial argument did it alone. It was the personal win. It was, when I do this, the pain in my chest goes away. So it is a hard sell. What are the personal wins for the people that you're trying to sell to? What is it that causes the pain in their chests? And I'll bet you can grab something out of your tool bag that will help make the pain in their chest go away, which actually segues perfectly to one of the points I wanted to make. Agile is not it's not a video game with levels that you're meant to conquer. It's not something that comes with a maturity model where if 80% of your if you have tests for 80% of your code, then you're AMM level 1, and if you have tests for 90% of your code and 20% of your projects are using continuous integration, then you're AMM level 2, and so on. There's no AMM level 5, which also means that there aren't a bunch of companies in India fraudulently claiming to be AMM level 5. There's no AMMI, none of that stuff. Because Agile is not meant to be a defined process to follow. It's meant to be a way for you to design your own process. This is one of the things that Alistair Cockburn absolutely nails perfectly in his work. He's interested in ways of helping teams find for themselves the method they need to get work done. Not following a designed or a defined process from a book, but finding the process that works for them to help them get work done. And this is another one of the things that has completely been lost in the idea of Agile. The idea that we are actually trying to use our minds and our observation skills and our communication skills to figure out what we should be doing and then do it. This is what Alistair Coburn talks about when he talks about, what the only question I want to have answered at the end of a project to determine success is, would we do it that way again? Yes, successful. No, maybe less successful. Hell no is a serious problem. So one of the problems with Agile transitions is that you have a bunch of people who now they want to follow a defined process. The difference is now they're reading that process from different books. So they look at the 12 practices of extreme programming and they see it like a checklist. And that's not what it's meant to be. The 12 practices in extreme programming are meant to be etudes. If there are any musicians in the house, you already know what I mean. For those of you who aren't, an etude is an exercise that musicians use to improve their technique, but it sounds like music, as opposed to the really boring exercises that piano players or trumpet players or violin players use, where it's just playing scales or something like that. It's meant to be an exercise because it's a piece of music that has certain difficulties in it designed to practice a particular bit of technique. And there are wonderful etudes out there. Chopin are my favorites for piano. And, there's one where the right hand is playing everything in groups of three, and the left hand is playing everything in groups of two, and trying to coordinate the two together. And then it switches where the left hand is playing threes and the right hand is playing twos. And it switches back and forth. That's what the extreme programming practices were meant to be. They were meant to be etudes. They were meant to be things that you practiced. And then XP wasn't following the rules. It's how do we behave once we've mastered the rules? Once we know how to do pair programming, test-driven development, continuous integration, weekly releases, weekly planning, all the other stuff, when we know how to do that stuff well, when that stuff is under our fingers, the way piano players say it, where you do it without thinking, XP is, if it is anything, XP is how you behave once you reach that point. Which is, again, another one of these Zen-like things that we toss around that makes our lives more difficult. Because it's much easier to just look at XP as a set of 12 practices that you follow. Just like it's easier to look at Scrum and see the 2 spirals and say, I get it. So now all we need is Scrum Masters and product owners and programmers and testers and chickens and pigs, and off you go. So that's the sense, I think, the sense in which sort of, Agile is not meant to be that. It's meant to be, the notion of inspect and adapt from Scrum nails it perfectly. I actually use ideas from theory of constraints combined with Agile software development to figure out what should we do. So I think I want to take my last few minutes to describe this part. Here you are. This is you. You are in this context where you're in a project or you're in a company and things are the way they are. I know it sounds stupid to say that, but things are the way they are right now. One of the things that people like about Kanban method is that in Kanban method, we always start with where are you? Not where should you be, not do these perfect things, but where are you right now? You have a whole bunch of options about what you could do next because lots of stuff is wrong. Quality is bad, schedules are slipping, people aren't talking to each other, we've got the wrong technology for what we're trying to do. There's a whole bunch of things wrong and you don't know which problem to fix. And even if you knew which problem to fix, you don't know how to fix it. Well, it turns out that we can use ideas from theory of constraints along with Agile software development to help us figure out which problems to solve and how to fix them. Now, I don't want to get into too much detail here. I think that, if you sit and read The Goal by Ellie Goldratt, that'll give you a good place to start. That's where you can get the whole theory of constraint stuff. But I'm going to give you the really, really, really short version. So you are in a system. Here's you. A system can be measured in terms of its throughput. So the system spits stuff out and takes stuff in. The rate at which it spits stuff out is called the throughput. How we measure that is not important for now. Just every system has throughput. If not, then it's not doing anything. Now, a system is made up of a whole bunch of things that have to happen in order to end up with throughput. It's just a bunch of stuff. You, your colleagues, the machines, the coffee machines, the car that took you to work in the morning, all that's part of the system. And stuff has to happen in order to have throughput. Now, what comes into the system is called investment. Investment is money that I put into the system. I buy things like programmers. That's an investment. Computers is an investment. Anything that we don't just use up. Anything that we buy and has value and is in the system for a period of time is investment. And then we have operating expenses. Operating expenses are things like heat and light, rent, insurance. These are the things that are they're not actually part of the system. But we need them in order for the system to run. And so then the system is about essentially using operating expenses to turn investment into throughput. So this is the money we have to pay for the privilege of turning money into other stuff. And the goal is to figure out ways to increase this while decreasing the other two. That's the goal in 5 minutes. Now, every system has something called a bottleneck. Here's the bottleneck. Sometimes it's a person, sometimes it's a thing. It could be a computer, it could be a process that we decide to follow 80% of the time. The bottleneck is literally that. It's the point at which the speed through the bottleneck slows things down, right? The job of a bottleneck is to slow the flow of liquid. If you take the bottleneck off that bottle and then try to drink that beer, more of it will end up on your face than inside you. That's the point of a bottleneck. A bottleneck is there to intentionally slow things down. Well, every system has a bottleneck. If it did not have a bottleneck, the throughput would be infinite. So there's something that constrains the amount of throughput that you can get for that investment using those operating expenses. So then the first part of the theory is there is a bottleneck. The bottleneck constrains throughput. The throughput at the bottleneck constrains the throughput of the system. This is the key point. What this means is that no matter what we do, if we don't increase the throughput of the bottleneck, we will not increase the throughput of the system. It means that identifying bottlenecks becomes kind of important. Now let's go back to you trying to figure out what to do next. The place is burning around you. They're talking about going agile. Now they want to do daily scrums and they want to have a maturity model. What the hell do I do? Look for the bottleneck. If you can find a candidate for the bottleneck then becomes a problem to solve, an urgent problem to solve. And the urgent problem to solve is increasing throughput through the bottleneck. That could be a person who is the only person who knows how to do 12 important things. In which case, get that person pairing with somebody. There's an agile technique that helps with increasing throughput through the bottleneck. It doesn't actually matter what that person was doing before. The fact that that person is now pairing with Chuck, who's the only guy who knows how to do 12 important things, and is not writing code on Project XYZ doesn't matter, because Project XYZ is not the bottleneck. The other consequence of this is the fact that if we improve throughput over here, it doesn't matter. What it also means is we can probably decrease throughput at those parts of the system. And as long as that throughput doesn't get below the bottleneck, it doesn't matter either. We have free resources that we can use to deal with the bottleneck. Which means it doesn't matter if my project slows down so that Chuck can speed up. As long as my project does not slow down to below Chuck's throughput, I should just give him everything. And then when I become the bottleneck, he gives me some stuff back. We balance, we're good. Now we can look for the bottleneck somewhere else. So finding the bottleneck helps you figure out which problems to try to solve. And then all the other stuff that you read about Agile software development, the XP books, the Scrum books, the Kanban books, the FDD books, the Lean development books, they give you the tools that can help you solve the problem. So if the bottleneck really is Chuck, then one simple thing you can do is get someone to pair with Chuck. And the rule is, you get Arlo Belshie's paper called Promiscuous Pair Programming in Beginner's Mind. And in that, he has two simple rules. Switch pairs frequently, and whoever is less confident about building the feature should be the one to stay. Because then information flows at maximum speed through the team. If Chuck is really the bottleneck, then you get somebody to pair with Chuck. And the rule is Chuck never touches the keyboard. Chuck's job is to sit there and tell the typist what to type. And slowly but surely the typist starts to learn what Chuck is thinking. After a while, the typist starts to think like Chuck. He knows what Chuck knows. Now you have a second Chuck. Throughput through Chuck has just doubled. Either that has moved the bottleneck to some other part of the system, or it hasn't. If it's moved the bottleneck to another part of the system, time to go hunt the next bottleneck and figure out what practice is going to help. And if the bottleneck is we're spending 70% of our people's time on support cases, then my guess is that the bottleneck is the rate at which you are producing defects. So you might want to try something like test-first programming, which, although it increases overall cost of features at the beginning, helps you eat away at the rate at which you produce defects. Now, that doesn't mean that you become perfect zero-defect programmers, but what it does mean is that you drive the defect rate down enough that that's no longer the bottleneck, and then the bottleneck moves somewhere else. So the combination of theory of constraints thinking and treating the Agile world like a bunch of tools in a toolbox instead of a maturity model or levels on a video game. Theory of constraints helps you figure out which problems are urgently in need of solving, and the Agile toolbox gives you some tools to try to make things better. And that's how that to me is maybe the single most powerful thing that you can do. So that leads me to the one classic question, which is, okay, how do we make our Agile transition work? How do we adopt Agile practices and not go crazy? This is how I do it. I teach people how to map their value streams and look for bottlenecks, and how to look at the books about extreme programming and Scrum and Kanban and FDD and Lean development and all the rest for ideas about what to try. And then I encourage them to run experiments. So an experiment would sound like this. Someone stands up in a meeting and says, I propose that we try test-driven development on all new features for the next 3 months with the goal of reducing the average rate of producing new defects by 90% compared to the last 6 months. Now, all of that was important. What practice? When are we going to do it? How long are we going to try it? What are the conditions in which we're going to do it and not do it? I don't want to get into that argument. We said we were going to test drive everything. No, we're going to test drive all code for all new features. Is that a new feature? Yes, then test drive it. You agreed. What's the goal? The goal is to reduce the rate at which we produce new defects. By how much? 90%. Why is the 90% important? I do not want to get into the argument about whether we made it 88 or 92. We have to make it a binary decision. We want to know that at the end of 3 months, we can look back at the numbers and say pass or fail. Now, what's built in is that if the experiment passes, if we achieve our goal, then the experiment automatically renews. We keep doing test-driven development. And for extra bonus points, you could say for twice as long. So it's like the contract has been automatically renewed for 6 months. If the experiment fails, then we don't do test-driven development anymore. And if somebody wants to repropose the experiment, they are free to do that. Now the question is, in what mood are we going to be to try again? What if our defect rate goes down by 84%? 84 is not 90. We said 90. I think the odds are pretty good that if you say, you know what, I know it was only 84% instead of 90%, but I think it went pretty well, let's try it again. There's a very good chance that the rest of us are going to say yes. But what if we only reduce defects by 22%? That's a sign that the bottleneck was actually somewhere else. And we guessed wrong, and that happens. This stuff ain't easy. If it were, I wouldn't be here. Or what happens if it turns out to be a total disaster? Well, that's one of the reasons why I make it 3 months. You see, I have a theory that I could probably handle a prison sentence of 3 months. So being forced to do test-driven development against my will for 3 months is not that much of a hardship. In the worst case, I just put my head down and it'll all blow over. And in 3 months, we won't get the results we expect and it'll be fine. So the reason to adopt practices this way is to deal with sort of both ends of the spectrum. There are some people who, no matter what success we have, will pretend that it wasn't because of the thing that's actually helping us. No matter how much success we have, they're just not going to like test-driven development. And there's the people at the other end of the spectrum who will say, no matter how badly things are going, if we just try harder, it'll turn around. I want to get rid of both those people from the argument. So by setting it at 3 months and having a clear goal, the person who is not going to like test-driven development, not going to want to do it, you can say to them, look, man, it's 3 months, calm down. At the end of 3 months, if it really was as bad as you said, we will take you out for drinks and you can yell at us all you want. Free of charge, 24 hours, yell to your heart's content. Tell us how stupid we were, we'll take it. But at the other end of the spectrum, if after 3 months it's not working out, then that cheerleader over here who says, no, guys, we just have to try harder, you can say to them, look, we gave it a real shot. You know we weren't sandbagging. We really tried. It just didn't work for us. That doesn't mean TDD isn't helpful. That doesn't mean that it's not helpful to us. It means that there's a bigger problem we need to solve more urgently. Let's focus our attention there. And so if a bunch of people want to still do TDD because they find that it's personally useful, let them. But we're not going to make it an institutionalized rule anymore. We got to focus on something else. So you can read The Goal to learn more about the theory of constraints as a thinking practice. And the other one, I think, is, I'm going to make sure I get the title right. I believe it's Implementing Lean Software Development. From Concept to Cache, which ties together a little bit the notions of theory of constraints in Agile software development. They just use the word lean because it's Mary and Tom Poppendick, and that's lean is their thing. And I think lean kind of probably stands the test of time a little bit better than the word Agile does. So I think that's everything I wanted to say. I know I went a little bit over time. No, actually a lot over time. I apologize for that. Here are some ways that I think you can survive your inevitable. By the way, inevitable because it seems like Agile's become such a fashion that the odds that you go through this through your career and don't run into Agile are pretty low. So here's how you can go Agile without going nuts. When in doubt, gather feedback. That's the essence of the Agile mindset. If you learn nothing else from tonight, that's it. If somebody's talking to you about going Agile and they're not working hard to gather feedback, then tell them, hey, dude, You know, you keep saying Agile like you know what it means. Here's what Agile really means. If you're going to do Agile, let's do it. That means that when you are in a moment of doubt, in a moment of crisis, you don't just sit and think harder about it. You gather feedback. You go figure out what's going on. Talk to the seniorest person you can, preferably someone in or close to finance, and ask them, hey, do you understand that if we do this Agile thing, that we're focusing on cash flow instead of long-term return on investment? Is that really what we want? Like, you know, if we don't have a cash problem, why are we doing this? If we're not trying to improve our cash position, why are we doing this? And see what they have to say. If you get somebody giving you a hard time about refactoring, just say, look, man, all I'm trying to do is reduce the volatility and the marginal cost of a feature. What don't you get? Practice that phrase. It's awesome. But more than anything else, this gives you an opportunity to look at someone who's a business stakeholder, who sees refactoring as a cost center, that sees it as a way of sucking money out of their pocket, and get them to understand that you're in fact trying to do something that they want. You're trying to make the stream, if you want to say this in less economic-y language, then just say this: I'm trying to smooth out the stream of new features. I'm trying to get you new features in a more predictable pace. First it gets predictable and then it speeds up. Don't you want that? Yes, I would. And finally, I said Agile projects. That's not what I meant to write at all. Oh. Let me edit that part out. Theory of constraints and Agile practices. If you start seeing stuff that looks an awful lot like Agile checklists and Agile maturity models and all that kind of stuff floating around your company, hit the red button. Find the seniorest person who will give you the time of day and say, look, I see these Agile checklists and stuff running around. Can I talk to you for a second about how Agile is actually supposed to help the company? Because I get the feeling someone missed the memo. This isn't meant to be a defined process. This is meant to be a way to find problems and fix them. And the way that you're going about it doesn't look like it's actually doing that. And that might be news to them. They might actually know all this. And somehow, as the message has trickled down, it gets distorted. I know that never happens, but it might. So find the most senior person who will talk to you at all. And say, I have a problem. I see these checklists running around. I see people doing stuff that sounds like Agile maturity model, and it ain't going to work. I can tell you, guaranteed it ain't going to work. Can I talk to you about what will help instead? And get them on your side. And then maybe that person will walk you into their boss's office and say, could you please tell my boss what you just told me? And then maybe she will walk you into her boss's office and say, will you please tell my boss what you just told me, until eventually maybe you are in front of the CEO. Do you understand that if you adopt Agile by having Agile checklists and Agile maturity models, that you are throwing money down the toilet? In fact, you're doing it at an accelerated rate. You should have gone back to what you were doing before. If that doesn't make them pay attention, nothing else will. And that's, I think, how you can survive your inevitable Agile transition, is to keep these things in mind. And yeah, it's okay that a lot of them aren't going to get it. So I'm going to say one thing that will just make sure that your employers never hear. And that is sometimes the way to survive your inevitable Agile transition is to look for opportunities to practice these things in your daily work, as much or as little as you can. Even if you get pushback from people around you, even if they think you're nuts, even if they actively try to sabotage you, look for ways to practice this stuff in your work. Find the people at your work who think the way you do, who have similar sensibilities to you and share the mindset. Find people in groups like this who share that mindset. And if you talk about it long enough, it's a very good chance that one of you at some point is going to say the magic words, you know, I bet we'd actually have a really good little lean startup right here. That's called the entrepreneurial seizure. It's great. Give it a shot. Read the E-Myth. Don't let it stop you. That's all I have to say. Good luck. This stuff kind of helped keep me sane trying to figure all this stuff out. And I really hope it helps you. And if it doesn't, all I can do is apologize. Thanks very much for your time and attention. I've got nothing more for you.